Well, hello friends. Welcome back to browser hacking. Today we are going to implement prototypes in JavaScript. So basically we want objects to have a prototype, and if something is requested on an object and we don't find it in the object, we want to ask the prototype, hey, do you have this property or this method or whatever? As long as the prototype has a prototype and so on, we have to go up the prototype chain, checking for the presence of properties until we reach a null value. So very standard JavaScript mechanism if you're familiar with the language, but we don't have it, so we should implement it. So I guess we will start by making a test case. So how about something like char@? Not JSON. So foo is the string foobar, and then we should print the foo char@3. So I was looking into this a little bit, and the way that I understand it is that what should happen here is that when you call, well, first thing is you're calling char@ on the literal, right? So this sort of implicitly creates a string object with foo in it. So this happens automatically. We've already done that in another video. And then it looks for the char@ property on the string object, so string char@, but there is no char@ there. At least there's not supposed to be, but instead it's supposed to be on string prototype. So string prototype has char@, and of course string prototype is a string prototype object that we're going to come up with, and string prototype prototype is null, I guess, or maybe it's object prototype actually. I'm not really sure, but we're just going to start by giving string a prototype that's a string prototype object, and then we're going to put the char@ thing on there. And then I realized that I just erased my whole thing, so we'll just write it out again. Print foo char@3. Okay, so we want this to print out B, then we will be happy. So if we just run this right now, let's just see what would happen. Okay, so assertion failed. And our AST, let's just see it. So our AST looks pretty sane, so we declare a variable, foo, string literal foobar, and then we call print with the result of call foo.char@. Arguments are 3. Okay, yeah, that's good. So a couple of things, we're going to need a couple of things for this. So first thing is that when you call foo.char@, we need the char@ thing on the prototype, and when you use a prototype to implement functionality, then you need the this object to refer to the thing that you're calling it on. So there's a whole bunch of things, but I think we'll just jump right into implementing this, and we'll figure everything out as we go. So starting with giving objects a prototype. So we can just do something like this. Maybe we'll have a const variant of that as well. And I think the prototype can just be an object. And of course we are going to have to visit this when we are doing garbage collector marking. So we'll say visitor visit and prototype. I guess if and prototype. Okay, that ensures that as long as an object is alive, we will keep its prototype alive as well. And maybe we'll have a set prototype. Okay, there we go. And then The part where we have to actually care about this, I mean, we have to care about this in a bunch of places, but the most obvious place is the get implementation, where we look up a property name in an object. So instead of what we've been doing so far is we just look in the property map of the current object. But now we need to actually walk up the prototype chain. So I guess while object value is, so we're looking it up at this step of the chain, and if we find it here, oh, should be const. If we find it, then we will, if we find it, we'll return it. Otherwise, we will go to the next step in the chain. And if we don't find anything, we will return JS undefined. That seems generally reasonable, I think. So, and let's not worry about put and that stuff right now. Let's just care about get. So now we will walk up the prototype chain for the object that we are querying. So then the string object has the length property here. I think this should actually be on the string prototype, but since it's a property and not a function, we don't have the facilities to move that right now. We'll get to that in the future. But when it comes to the charadd function, then let's put it on the prototype instead. So we'll do something here like setting a prototype, and we can just allocate a new prototype for now. String prototype, something like that. And I guess we need heap and string prototype. And then we have to actually declare whatever this is supposed to be. So JS string prototype, and I think we can start by making them kind of the same as string object, but then they will diverge a little bit. So starting with string object, string prototype, but we will instead, of course, do this, and it's not going to have a primitive string inside of it, and it's not going to have any children, so it doesn't need to visit any children. The constructor only needs to be like that. Yeah. And then we can get rid of that, and is it supposed to be the object prototype as the, let's see, new x is new string x. So how do you get the prototype here? Like this? Proto. Okay, so his prototype is object, and then that guy's prototype is null. So actually, the string prototype should have the object prototype as his prototype. So I guess we can do that right away. Don't need that. And let's just see. So this will be good, actually. This is going to make the language start to feel a bit more real, I think. A bit more dynamic. So string prototype is an object. Right. So I guess in object, we want to set our prototype to object prototype in the constructor. Heap allocate object prototype. I think the basic idea here is right. And we probably want this to be global, like have a global object prototype. So we'll get to that. But right now I'm just going to instantiate a new one every time we create an object or a string object or whatever. So this will be fine. String prototype. Okay, let's do object prototype as well. Oh. And his prototype is null. Cool. And object prototype is going to be exceedingly simple. Actually, it will be the same as string prototype in the header, but yeah, this is our object prototype. It's good. We'll need to add some functions to it later, but for now, this will be good enough, I think. So now that we have this set up, then we want to do a little bit of, I guess we want to add some function here. So put native function char at, and what do we want to do on that function? Have a vector value arguments, and the return value is a value. I'm starting to get used to typing these out. Expected body of lambda expression. Oh, I did not put that in the right place. And there we are. Maybe I'm not so used to typing them out. Okay, so here is our char at implementation. So if argument is empty, then I think it defaults to 0. So we'll just say something like index is 0. If arguments is not empty, then index is argument 0 dot to number. Apparently we don't have that, so we'll have to implement that. We have ask double, but what we really want is something like to number. What does it do? Maybe we'll even do this, to I32. Because that's the number that we actually want. So in value, we'll say, oh wait, this is weird. To string, to boolean, to object, value, to I32. And switch. It's not supposed to return a value. Switch in type, case type, and number. Yeah, so we're storing it as a double internally, so we'll just do an implicit conversion here, or an explicit conversion. And I think for the others, we'll just assert not reached, and we'll deal with this at some point in the future. Maybe we can do boolean as well. So boolean. 1 or 2, 1 or 0. something like that. Probably just do it that way, because that's a bool, yes. And converting a string or object or something to an 32-bit integer, I don't want to deal with that right now, so we're not going to deal with that right now. We'll deal with this, and then this will assert if we can't convert it. Okay, and then we need to get the character at the index, right? So that would be first we need the underlying string. So underlying string is oh yeah. So now comes an interesting part here. Now, when you're calling a string prototype function, we don't want to call it. We don't want to look into the string prototype object for the underlying string because it's not there. You're calling a string prototype function on an object that just happens to have the string prototype as its prototype or in its prototype chain. So what we want to do now is we want this value, and we don't have that. So we need a way to get that, right? And what we're going to do is we're just going to ask the interpreter for the current this value or something like that. And I think we need to interpret it like that. Okay, so this is not the underlying string, actually, it's the this value. And I'll say that it's a value. And we'll implement that momentarily, but once we have it, then if this value is object, we can actually assert that it's an object, and we can assert that as an object it is a string object, and then we will static cast it to a string object, this value as object. Underlying string is string object. We want the primitive string inside of it, and we want the string inside that. I think we don't have a primitive string getter on string object. We can just add it. So primitive string. String, yeah. And we can't call, oh, it's a pointer. Oh, yeah, right. And it's supposed to end in a semicolon. Okay, so now we just need this value and the is string object. So is string object, very straightforward. We'll just put it here on the string object. So virtual bool is string object. Return true. And of course, on object, we'll just have this string object, and we'll just say no by default. Simple. Okay, and then this value. We can write the rest of the function before we do this value, actually. So now we want to return a new JS string that is the single character at the index requested. So the underlying string, substring, starting at index, length 1. Okay. And this is not captured. Oh yeah, right, we don't have this. So we'll just get the heap from the interpreter instead. Right, so about this value. So it's a little unclear to me how this value is supposed to work in JavaScript, but at least in this context I understand that if you call like .char@, on a string, even though you're executing a function in the prototype, that this value is supposed to be the string that you called it on. So we can implement that behavior. So what we'll do is, I think we'll just do like a simple stack, because I don't think it fits with the scope stack perfectly, maybe I'm wrong, but we'll just put a stack next to him. We'll call him like this stack or similar, something like that, and then we can have something like push this value, this stack, append, move value, pop this value, and here we'll just do take last, do pop. We're just using a vector as a stack, it's fine. And finally this value. So that will be if this stack is empty, then return the global object, otherwise return this stack at last. So this is probably not correct in many cases, and certainly not if you're running in strict mode or something like that, but you know, one thing at a time, right? This should cover our use case, which would be for the call expression. When we call something, then we want to say, hey, interpreter, push this value, and afterwards we want to pop this value to remove it, and we return the result like that. And this value is the I was asking Conrad about this earlier today, and what the heck was the conclusion? That this value is the left-hand side of the left-hand side of the object that you're calling. Wait, how does the AST look again? I forgot. Chart. So we want this guy, this call expression. We want this value to be this guy right here. So if we're calling something and the thing that we're calling is a member expression, then we want to look at the object in the member expression, I guess. So the left-hand side of the member expression determines this value of a surrounding call expression. I think. Let's try that. So let's see, if mcallee is a member expression. Apparently we don't have that, but we can add that. If it is, then this value is JS defined. Okay. This value is mcallee. So it's called m up static cast to a const member expression mcallee dot. We want this guy right here. So I guess object, right? Object, and we want to execute that in the interpreter, and that will give us this value. I think. Okay, and then if this value is, so if it's not undefined, then we'll push, and if it's not undefined, then we'll pop. Right. Does this make sense? I hope this makes sense. I think it makes sense. So we just need is member expression and a way to get the object out of the member expression. Return true. And const false, and in the member expression, then we just need const expression object. Cool. So now we execute the object expression to give us this value. It's a little bit gunky, but I think it will be okay. So now when we call here, we'll call this native function and we'll just run the callback, and in that callback, this value will be the left-hand side of the member expression inside the call expression. Yeah, okay. Let's try it. Wait, that's not making userland. That would have gotten confusing. That got extremely crashy. What the heck? Crashed the Windows server. What did we do? Oh shit, look at that. Stack overflow from an infinite loop. Why did everything else die? That's so weird. Null dereference in the kernel. Ooh, gross. I think we hit some gnarly race there in the CPU graph menu applet. It's trying to, I guess it's like trying to get data about a dead process. Funny. Null dereference though, so it's not that scary, but still the fact that, I mean, there are races in the kernel, and we got to fix all of those. But right now we're building a JavaScript engine. Can't do everything at the same time. So this is obviously a bit weird. So the problem, of course, is that object prototype or object instantiates a new object prototype, which is an object. So didn't really think that one through, did I? So I guess this brings us to an optimization I wanted to do anyway, which is to have, or probably it's also for correctness, to have a global object prototype rather than a new one in every object. So it's more, of course, it's more than an optimization. It's needed for correctness. So what we'll do here is we'll say, should we require passing a prototype to these things? I don't know. Maybe that's not necessary, but what we can do is we can say object prototype the. We can do something like that for now. And we'll just make one of those, static object prototype. But wait a moment here, what's gonna happen now? Because object prototype is an object. The order here is a little bit annoying. Maybe we'll just not give object a prototype right now, and we can get back to that later. When we have some more, we have a smaller problem space, because now the problem keeps growing. So char at, okay. So now we're getting this value is object assertion. So we're failing call expression, and then in the native function, I guess we are looking up to this value and figuring out that this is not a this is not an object with this value. So why not? I guess this is the part where we would have come up with a more interesting this value. So we'll say, wait, did I do that one correctly? Yes, I did. Okay. And this value. Okay, let's just see what this would log. It's foobar. It's foobar? Wait, what? So the string itself, right. So that makes sense. Oh shit, yeah, we have to toObject. So we have to toObject him so that we, since it's a literal, then we want the string object. So we have to actually call toObject to make sure that we don't get the literal, but we get a string object. So I think maybe that will do the trick. All right. B. And look at us sweeping all those dead cells. Pretty cool. Okay, so B is, I guess, third. And if we start on 0, then it's the third character here. B. So that's pretty cool. Actually, let's play with this in Hack Studio, since Hack Studio can now do some basic JavaScript stuff, thanks to Orico, who worked on this. So, see, we can run it like this. And then we can edit this here. And changes down here, very cool. What if we do 0 run? That works. What about -1? Does that work at all? Fails to parse. That's funny. And what about 200? Crash. I think if you do, okay, let's look it up. String prototype char at. What does MDN say? Blah, 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 blah. Return value. If index is out of range, it returns the empty string. All right. So, by the way, how nice is this, right? We can actually run JavaScript here. Fascinating. Isn't this fascinating? Well, I like it. This will be very good once the engine starts to become a little bit stronger. Then we'll probably be able to work on it here instead, which will be very cool. So this value can get rid of that, so that's working. And now we just wanted to fix that out of bounds issue for char at. So char at string prototype. I guess if index is greater than or equal to the underlying string length, then, or if index less than 0 or then we return JS string interpreter heap string empty. Okay, let's try it with a huge string, see what happens. I mean, with a huge index. Just an empty string comes out. That's so neat. Okay, so I made a bit of a mess with the object prototype stuff, so I think maybe we'll skip over that at the moment. Yeah, let's get rid of that for now, and we'll come back to that. So, what did we... let's do some commits here. Maybe we can do some separated ones. So let's diff these guys first. I think that's only the two I32 stuff. Yeah. Add value to I32 helper function. Okay, and blah, 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 blah. JS makefile object prototype. Let's get rid of him for now. Okay. Okay, and then we add this guy, this guy, this guy, this guy, this guy. JS. Add basic prototype support object will now look traverse up the prototype chain when doing a get. Object when a function is called on an object, that object will now be, also be this value inside the function. This stuff is probably not very correct, but we will improve things as we go. Great. So, oh, right, I have to do the string changes as well. JS. Get add string prototype and make it the prototype of string object. This patch adds string prototype char add to demonstrate that prototype property lookup works and that you can call a prototype function on an object and it will basically do what you expect. Cool. So let's see where we start now. I didn't like that the string object instantiates a new prototype every time. So we should put those things somewhere and then only have one of them. And I guess we could put them on heap, but it's kind of a weird place. I would like to store them on the interpreter, but I don't have a way to get there from here. But maybe we can get there via the heap. Maybe we can make a helper like this, interpreter dot. Proto get something like this. Prototype. Okay, so how do we get to the interpreter from here? That's an interesting question. So I guess maybe the heap already knows who the interpreter is. Yes, it does. Okay, so heap. How does it store it? Interpreter. Okay, so we can get to the interpreter from the heap. So this would work. Interpreter. Interpreter. That's fine. JS interpreter. We could also have a convenience function for this, I guess. So here's heap, and we could make we'll just do this heap interpreter. Okay, now we just need interpreter to have this thing. So how will that work? Let's see. Maybe this is overkill. Actually, we can also just do like string prototype. That would probably be good enough. So I was thinking, like, how do we templatize this in a non-annoying way? And I kind of don't want to right now. So we can just say string prototype. String prototype. And we'll just put that down here and string prototype null pattern. Okay. And then we got to make sure that we, oh shit, we forgot to collect roots, this values. We need to collect those for the garbage collector. Let's do that first. So any this value should be considered a potential root for marking, I think. Maybe it's redundant, but I think we should do it anyway. So actually, it's not redundant. This value in M, this stack. If this value is cell, then roots set it this value as cell. Yep. Interpreter. Interpreter should make sure that this stack gets marked. Okay. And I think we can just add those convenience helpers here. And I think that was this one as well. Just a way to go from any cell to the interpreter. Add a cell interpreter convenience helper. This allows you to go from any cell to the interpreter. To the interpreter. Okay. So we just have to make sure we collect, and we don't garbage collect the string prototype, but we mark it. Okay, so we mark it. Maybe collect roots is kind of a weird name actually. Maybe it should be called gather roots instead. because collect kind of implies that you're collecting the garbage, right? Terminology is a bit messed up here. But we can fix that soon. So what we've done now is basically not allocate that anywhere. So we'll do it at the same time that we set up the global object, which I guess is in the interpreter constructor. So here we'll do string prototype is heap allocate a string prototype. All right. And we should do the same for the object prototype. We'll get there. Let's just verify that this works. The way we know that it works is that if we run the JS command, then it will do a garbage collection when it exits. So we should see that the string prototype survives. And we can see that here is a root. It's considered a root string prototype, and it is live, obviously, since it's a root. All roots are always live. And we sweep some dead cells here, but none of them are the string prototype, so it survives. That's cool. Very, very nice. Okay. So I think commit a JS. Use the same string prototype for all string globally. Interpreter. Let's see. To make sure that everyone has the same instance of string prototype. Hang a global prototype of the interpreter that can be fetched when constructing new string objects. Alright. Let's do that rename that I mentioned. So collect roots. Slightly overloaded term here, so let's call it gather instead. I think that would be better. It's a small change, but since it's a garbage collector and this is specifically not what we should not garbage collect, I think calling it collect is wrong. So the JS rename interpreter collect roots to gather roots. Since this is about finding the things we should not garbage collect, it seemed wrong to call it collect something. Okay, so wait, let's just see, what do we call the function that calls that? It's called collect roots. Okay, so let's rename him as well. To gather. Yeah. And then we'll just merge that into the previous patch. Okay, and it's a nice little change. So let's see about the object prototype. So if for the interpreter we can just add a object prototype thingy, and it will be a root here as well. Object. Okay, and then in the object thing, we can just say set prototype interpreter object prototype. interpreter. So what's some interesting function on the object prototype that we could add for testing? How do we find some? Standard built-in objects. Oh, well, I want object. Object itself. Object dot prototype dot. See, object has its own property, own things as well. Interesting. I would have thought that get own property names would have been a function on object prototype. Maybe it's not. Well, what do we have? Object prototype has own property. Is there some way to get the prototype? This way you get it. Well, I want to add something on it though. So object prototype has own property. We can implement that. So it just tells you if an object has a property and it doesn't look in the prototype chain, but it only looks at the individual object. So we'll add that function here. So put native function has own property. Arguments. And we need some includes, so value, and I think act function as well. And string is incomplete. Wow. Okay. There we go. If argument is empty, then just return J as undefined. There's going to be so many correctness fixes in this engine over time because we're really just winging it a lot, as you probably noticed. But I'm a firm believer in winging it when you're bringing something up, because if we try to do everything perfectly correctly all the time, then it's not going to be getting anywhere. So let's see. Has own property. I guess we want to do the same thing as the string prototype did to acquire this. So in this case, we only care that it's an object, really. And we have the interpreter. Then we need the declaration of interpreter. Okay, so return object this value as object has own property. We'll just add a helper for this. So argument 0 to string. Okay. And then on the object class, let's add something here. So bool has own property. Const string, yes, because we're not going to take ownership. Property name const. And it's as simple as not prototype, looking into the properties. So properties get property name. I think it's really that simple, at least my naive understanding of the functionality. Oh, it gives us an optional. So pass value. Okay, it's going to increase header dependencies here, so let's just move it out of line. Oof, object has own property. There we have it. And interpreter needs object prototype, of course. So what this should allow us to do is we should be able to look up at least on a string object, I'm thinking like what has an own property. So we have any string object will have length as an own property right now. So that will allow us at least to see that that works. We don't have a way to set own properties at the moment. But we'll get there too. We're not going to do everything today. So this still works. Oh wait, I wanted to bring up Hack Studio so we can mess with it here. So I guess we can check foo dot has own property length. This should give us true. And it fails. All right. Why does that fail? Object has object prototype as its prototype. String prototype. This. Wait, what's failing? Callee is object at 58. So we're trying to call something on something that's not an object. Okay, so how can we salvage this? Foo. Wait, why does it think it's not an object? What's the AST? Let's see the AST. Okay. So calling print on the result of a call expression. Call foo has own property length. So I guess we didn't find has own property in the chain. Has own property. It's an object prototype. Wait a minute, I'm not even compiling this. Why am I expecting this to work? Okay, I was not even compiling it. Has own property. We have to turn that into a value. Oh. Okay. Navigating here is a little bit weird. Okay. Foo has own property bar. That fails. Okay. Callee is object. Let's see if we ever end up in here. Has own property. And let's see about string, or let's look into object get. See everybody that he tries. So get trying property name in object class name. Yeah, shit. I should probably make a test case that I can use here. Has own property JS. Alright, var x foobar. Print x has own property length. Okay, so it's trying has on property in string object, it fails. Tries has on property in string prototype, that fails. Oh, wait, hold on. I know why this is. Because when we're constructing the the string prototype, this will try to set the string prototype to the object prototype, which hasn't been constructed yet. So they're just in the wrong order. Okay, so that works. Very, very interesting. So has on property length totally works. Length x totally does not work. That is really cool. All right. So that means that we get object prototype and an implementation of has on property. The JS add object prototype and and implement object prototype as own property. I mean, I guess that's fine to say it that way, as own property. All objects will now have object prototype as their prototype, unless overridden. Yeah, because string prototype will override. Or not string prototype, sorry. So string object, which would normally have object prototype as his prototype, he will override it in his constructor by setting the string prototype instead. So I think this mechanism will work. We'll do this. And of course, eventually we're going to move length here. I think we're supposed to move it. Let me double check that actually. Can we get the string length? Yeah, it's supposed to be string prototype length, but we don't have like getters yet, so I can't move that. I can only do functions. Anyways, I think we have gone pretty far today, so I'm really happy with it. And I think this will be the end of today's video. So if you made it this far, then I thank you for watching, for hanging out. And I hope you saw something interesting here, because this is pretty interesting to me. So I hope it's interesting to other people. Thank you for hanging out. And man, this is so much fun, right? Like, can't wait to see what we do next. Yeah, see you next time.